what electric current is, and you know what a conductor and an insulator is. Now you can set up how charges can flow, which leads to the idea of electric circuits. Electric circuits can be as simple as connecting a battery with a wire, with a bulb, and can go as far as being complex with electric circuit that wires our home and a whole community, a whole region. Now, what is electric circuits? The electric circuit is just the path provided for the flow of electric current. Once you provide a path for the flow of electric current, what you have is electric circuit. Now, like I said, electric circuit can be simple. So for a simple electric circuit, you need 4 things to make up an electric circuit. And the first thing I will detail is your energy source. Energy source. For example, the energy source is going from power plant, that power holding company. But if you are starting small, our power source can be a battery. Your power source can be a solar energy, can be from different forms, from radioactivity. But now our energy source is a battery. That's one key thing you start with. It was simple electric circuit. Another thing is your conductor. Where is the electricity going to flow? Where is the charge going to flow? So you need your wire. Your wire is supposed to be the conductor. And another thing, the third thing you need is your load. Your load can be your can be your fan, can be your electric iron. But for a start, you can just play with a small bulb. So the third thing is load, and the last one is switch to complete the circuit or to break the circuit. So once again, there are just 4 things you need to start up a simple circuit, which is your energy source, conductor, load, and switch. Now, because of this switch, we can classify a electric circuit in theory. Because of this switch, we can classify electric conductor, electric circuit in theory. One is the open circuit. What is an open circuit? An open circuit is one that the key is open. There's no complete flow of electricity. Now, if you look at this diagram, this whole part represents a battery, your energy source. This is connected to one terminal of the battery, another terminal. This is your conductor. This is your switch. And this is your load, which is a bulb. Now, we open the key. So when you open the key, the current cannot flow on a continuous path. This is what we call a open circuit. The bulb will not turn. That's an open circuit, open key. When you have an open key, you have an open circuit. And when you have a closed key, you have a closed circuit. For a closed circuit, there's continuous flow of what? Charges. And in this case, the bulb will switch on. So you have open circuits when the key is open, you have closed circuits when the key is closed, there's continuous flow of charge. Now you also have a short circuit. This is a short circuit. If you notice, there is no load on this circuit, just a battery or metallic conductor. So there's no need for a key. Now, short circuits, in definition, is a closed circuit in which there is no load. So closed circuit in which there is no load. Now this is quite dangerous because at home, most of the electric faults we encounter is closed circuits. Electricity comes into our house with the live wire and goes out with the neutral wire. But once it comes through, the wire is the conductor. It passes through our appliance, which are the load. Anything that makes the live wire and the neutral wire to connect, you have a short circuit. That is, the wire are formed before the load, and it can cause a blow. So most of the thing what we have at home is short circuits. A short circuit is a closed circuit in which there is no load. Now, we have earlier talked about currents and we talked about resistance. Now, if you understand the two concepts, you understand that resistance is close to, there is a factor that determines current, how fast charges are moving. Because if you have high resistance, charges will not be moving fast. Then you have low currents. But if you have low resistance, charges will be able to move fast. The rate in which they are moving will be fast. So you have high currents. Apart from resistance, which is the opposition of flow of currents, there is still another factor, potential difference. It is also an essential condition for currents. Potential difference is also another essential condition for current. For short, we call potential difference PD. So when someone wants to say potential difference, I just say PD. But when you want to represent potential difference, we represent it with capital letter V. And the unit for potential difference is volts, which is represented with small letter. Please don't get it confused. Big letter V represents potential difference, while small letter V represents volts, the unit for potential difference. While PD is short for potential difference. Now, what is potential difference? What is potential difference? What is potential difference? So start, I would like to illustrate this diagram. For example, you have boxes on top of the glass, 3 blocks, and you put some balls on top of the glass. Now, if I should ask, if you place a ball here, will it move? Definitely it will not move because the difference is all the same in the surface of the bus. When I place a ball in bus B, the ball in the bottom of bus B, it will what? It will move because there is this kind of what difference. So the ball will move, and you can see your will also move, and it will move more. And when this ball now moves, when you get to the floor, it will break this glass, and you can say work has been done. Work has been done. For this ball to move and do work, there must be a difference. The truth is that in a conductor, charges are just moving randomly. But for charges to move in a specified direction and do work, there must be some kind of electric difference. Electric difference. Electric difference. For charges to move in a specified direction, that electric difference is what some people call potential difference. But some people don't want to call it electric difference. You can say, you can look at it this way. This is like a tank. And you have pipe here, and you have pipe here. And you open these two pipes. You are moving out. Which one will the water come out with more? The water will come out more on the side below. Why? Because there is more pressure at the bottom. So charges move because there are more charge. There is what called electric pressure. So get it clear? If this was a conductor, there will be charges inside it. Now, the charges are not just moving in a specific direction. There has to be some kind of electric pressure or some kind of electric difference. The charges will not move in a specified direction. And as it's moving, what can it do? What is what fell on the glass? What did it do to the glass? It broke the glass. So it can do work. So let's define potential difference of time. Potential difference between any two points in an electric field. So that is the complete name of potential difference. For short, just potential difference. Potential difference is always between any two points in an electric field. The key word it is a what? Work done. The work done in moving a positive charge from one point in moving a positive charge of 1 coulomb from one point in the electric field to another. Potential difference between any two points in an electric field is the work done in moving a positive charge of 1 coulomb from one point in the electric field to another. The charge will have to move it. There has to be a difference. But that work done moving that positive charge, that difference, that will make that positive charge to move from one point to another is what we call potential difference. Now look at it very well. There must be a difference for one positive charge to move. Now here is just the unit of the charge. We are looking at the charge in the unit of coulomb. So there must be a difference. Removing one charge of 1 coulomb from one point in the electric field to another. So let us ask what is the key word for potential difference. So let's say potential difference in the words. Yes, is the work done moving up one positive charge. That's why I say pressure. There must be a pressure. Charges are not just move on their own. There must be some kind of electric pressure.
For electric difference for charges to move. And one charge moves, there must be work must be done. Once again, what is the unit for potential difference? And what is the unit potential difference is denoted with D, capital letter D. Now it's interesting to know that potential difference is just between any two points. Now when we look at potential difference around a complete circuit, potential difference is not called EMF. So another name for potential difference is called EMF. Only that it is not the work that you will be a positive charge of 1 coulomb around a complete circuit. Potential difference has to do with just any two points from here to here, from here to here, from here to here. What we are talking about the work that moving the positive charge of 1 coulomb around the complete circuit. We call it electromotive force, which is for short EMF. Another name for potential difference is also called voltage. As we move on, we may leave this name and adopt this name voltage. It's basically the same thing. Tell somebody wants to just pick one or two points. Voltage and potential difference is the same. At home, we don't say potential difference, we say voltage. And engineers use the word voltage. So voltage is the potential difference. So all of them basically have the same unit, which is volts. So what is the unit of PMF? Volts. just remain voltage. But now we stick with P, the potential difference. Now, like I said, potential difference is essential for charges to flow because if there's high difference, charges move faster, so there will be high current. So the two factors that will affect current is resistance and potential difference. Now, this case was a simple circuit. When we begin to add more things, we now have a complex circuit. That circuit, printed circuit board, like your remote, your TV, your laptop, have complex circuit board, and you see a lot of things. So that's a complex circuit. But a simple circuit does consist of these functions. Now, as we want to improve in our circuit, some of the things we can add to our circuit is a voltmeter. A voltmeter is a device for measuring resistance. So when you add a voltmeter to your circuit, you now have that to connect it to parallel. And you can add an ammeter to your circuit, but you have to connect it in series with your power source or your cell. Exactly. So you can begin to add things to your circuit. The first you can add is voltmeter and ammeter. When you're adding ammeter, you're adding it in series with the cell. When you're adding voltmeter, you're adding it in parallel with the resistor. Now, as for ammeter and voltmeter, there are other things you can add. We want to start adding. You can add a inductor. These are electric components combined with resistor. Electric circuit. You can add a resistor. You can have a cell. A cell is a main component. You can have a capacitor. So, that inductor, resistor, and capacitor. We will take time to discuss what a capacitor is, a resistor